We're moving on to surface area of pyramids and cones. These are definitely a little bit trickier than the volume of these shapes would be. So make sure that as you're working through this, A, you're asking me as many questions as you need to make sure that you understand the material, but B, you have to draw out the nets for these shapes. If I see you not drawing out nets, you probably will be forced to start over whatever assignment you had started. So make sure, please, 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 throw out as many nets as you possibly can for these shapes. So as we work on the surface area of these shapes, one of the first things that we want to notice right away is that if we think about the net of the shape the same way we did with a prism, you can just simply break it up into a bunch of equivalent parts. The base of this shape is a square, but the pieces on the outside will actually end up being just rectangles. And because the base of this shape is the same, all of these rectangles will be the same as well. So if I take these over to the side and I do a little bit of rotating, I will end up making the net for the pyramid. So if it decides to slide. Now, so that means that there are 4 equivalent triangles and then 1 rectangle, and that makes up the entire pyramid that I'm working with. So I just need to simply find the surface area of each piece, and if I add them together, that will give me the total surface area. So the bottom figure is an 8 by 8 rectangle, meaning it has an area of 64 square inches. Then each of these rectangles are 8 by 10. Therefore, their area is going to be 8 times 10 divided by 2, which gives me 40 square inches for each of the triangles. I then simply add all of these areas up, which gives me, that would be 40 plus 40 plus 40 plus 40 is 160. 160 plus 64 is 224 square inches. And that would be the surface area of my pyramid. Definitely tougher than what we have been doing before, but not impossible either. Let's get a tiny bit trickier. So this figure to the left is a pyramid. It is also a square pyramid, but this time it gave us the direct height of the figure instead of the slanted height. Since we want to find the outside area, we need to figure out what the slanted height of the center of the side would be. So I took this 3D figure and I cut it into a vertical slice, which is 2-dimensional. I know that the total distance from here to here is 80. That means the distance from one of these sides is 40. And the direct height here is 100. Well, what I end up then getting is the Pythagorean theorem. I know our very, very favorite thing that we've done. So I'm going to take 40 squared plus 100 squared, and that will give me x squared, because x in this case is going to be the hypotenuse. So we will add together these two squares. So 40 squared is 1,600. 100 squared, well, that is 10,000. That's equal to x squared. So I take those two things and I add them up. And then I'm going to square root both sides. So I get 11,600 is equal to x squared. So I'm going to square root both sides. And I get x is about 107 7/10 meters. Okay, so what that means is that this figure from here to here is about 107 7/10 meters. Therefore, now I can simply do what I did in the last problem. The area of the bottom rectangle is 80 times 80, which is 6,400. And since this is a square bottom, all of the triangles will be the same. It's going to be 80 times 107 7/10 and divided by 2. So each of these is going to be about 4,308. So if I take that 4,308 and multiply times 4, then I'm going to add the bottom. So our total surface area is about 23,632. And this time it will be square meters. That is a 6, a little hard to read there. Okay, so if you're not given the slanted height, one of the most important things you have to do is calculate what the slanted height would be before you start working on the problem. So let's work on cones now. The cone is the same idea, except it is a circular base. So this is the radius of 18 inches. That's from here to the outside. But then the height of the figure is 1 foot. Well, the problem here is that we want this in inches. So I'm going to convert 1 foot to 12 inches before we start. And now I need to find the slanted height as well. So I know that this right here is 18 inches, and the direct height is 12 inches. And I'm hoping you're noticing that this is not drawn to scale. That's perfectly fine. So in this case, we're once again do 18 squared plus 12 squared is equal to x squared. So we do 18 squared plus 12 squared gives us 468, and that's equal to x squared. So I'm going to square root both sides, and I get about 21 6/10 for the slanted height. So this is what we can say S is 21 6/10 inches. You'll also see this called L. And L stands for lateral height. Lateral means slanted. So lateral height or slanted height. Now, when we're dealing with a cone, now that we have the slanted height, I'm going to erase everything here that is not helpful to this problem. So really try to simplify this page. Okay, so we have our lateral or slanted height. Whoops, let's try that again. Here we go. So when we draw the net for this figure, one of the problems is that if you cut this figure, take like a little box cutter and you slide it and you open it up, you end up creating this piece right here. It kind of looks like a fourth of a pie. There is a way to calculate how this formula is created, but I'm okay with saying that the area of this piece is pi times radius times the slanted height or lateral height. So you find that area right there, and then you do the area of the circle in the bottom, and once you add those two things together, you can find the total surface area of this shape. So if you are at this point and you're a little confused, which is okay, the surface area of a cone is going to be this formula, pi times radius squared plus pi times radius times the slanted height. And this is one of the few times that I am okay giving you a formula for surface area. So for this figure, the radius is 18, so I'm going to do pi times 18 squared plus pi times the slanted height, that's 21 6/10, times the radius, which is 18. Okay, so now I simply add these things together. So I do 18 squared is 324. I do that times pi, gives me 1,017, and let's say 9/10. We're going to add the second part, which is pi times 21 6/10 times 18. And that's going to give me about 1,221 45/100. Now I simply add those two things together. and I get a total surface area of 2,239 and about 4/10, and this would be inches squared. So, surface area is tough, especially of cones. If you are lost, this formula right up here is one of the only times I want you to have a formula written down in your notes, because I will not give you that formula on the quiz. As always, if you have any questions, please let me know.